Alright, so the next thing we're going to need to do is actually increment a cell up within the chunk we want to collapse. That way we can then reference from that. For example, we need to go from 0 to 1, so then we can reference 91. Now, how would we do this? All we need to do is understand the dimensions of our chunk. So this chunk has a width of 10, so we're just going to need to iterate through all 10 cells from 0 to 9. Height is also 10, so we'll just need to iterate through all of these cells from 0 to 90. And same with the top, it's just 90 to 99, that's still 10 cells, and 9 to 99, that's still just 10 cells, just these 10 individual cells. Perfect. So the first way we're going to do that is within the check neighbor. After we set our tile map, we need to run a for loop from 0 to a last index of a select for the directions as the index. The top and bottom will be the chunk width, so that size in the x, -1, and the left and right will be that height, -1. So left and right, we care about the height, and the top and bottom, we care about the width. Then we need to save that index. We're going to call it a local variable, just the for loop index. And the next thing we need to do is actually increment up that cell. So this is giving us a way to move things up, and now we need to add that into the actual cell. So if we are looking at the top direction, we need to somehow start at 90, go up to 91, 2, 3, 4, all the way to 99. And this will be done pretty simply. If we look over here, by just getting the width times the height minus the width plus that for loop. So 10 times 10 in this example minus 10 equals 90, and then we can just add on whatever the for loop would be. If it's 1, then that'll get us at 91 all the way to 99. And we can see we've done that here by multiplying width times height minus width, adding on the for loop index. The bottom is pretty simple, it is just purely the for loop index, and we can see that right here. For this cell is 0, 1, 2, 3, 4, all the way to 9. So that is very simple. And the next step is going to be the left. So we want this cell, and all that's going to be is 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. So these are all multiples of our height, our width. The height in this case is the same, but if we were to have a different width, let's say it were to be something like 15, all of these would be multiples of 15. And we can see that here, for loop times that width. And that works nicely because if we're on index 0 of the for loop, we'll get 0. If we're at index 1, we'll get 10, and so on. Similarly, the right direction will be the chunk size -1 added to that same kind of idea, that width, that size times the for loop. So all we're doing there is instead, we're just essentially subtracting 1 from what we had just done. But we're ensuring that it's done properly by first coming in here. So we need to get 9 as a first number. So we're going to grab, as we can see here, that size -1. And then that's added to that width plus the loop. Now what does this get us? Let's say we are on the 0 loop. So we have a width of 10 -1 plus 10. Oh, it's times. That is, I was like, that does not make any sense. Oh, there. Don't know why we're doing that, but that's okay. Okay, that should be times. Too many x's. Little multiplicative dot. All right, times 0 will net us a 9, exactly where we want to be, and this will increment up properly. So width minus 1 added to that width times the for loop, and that will be in the right direction. We're going to save that as the current cell. We're going to use this when we need to actually save in the what the cells should be. So once we get this information, we need to then save it within our generating chunk so then we can collapse accordingly. Now we need to actually find that neighbor cell, and this will be done pretty easily. So all we need to do is use our neighbor cell ref and add it to the for loop for the top and bottom. And remember, we set the neighbor cell ref all the way back here. It gave us a starting position for our neighbor cells and what they would be. For the left direction, it will just be the for loop times the width added to that neighbor cell ref, and the right direction will just be that for loop times the width. And we can see that here, the right direction, the neighbor cell starts at 0. Sorry, not the neighbor cell. We're just doing the for loop index times the width. So it starts at 0, then we multiply it, and it continue up. It's the same as what we just did for this left side while we were getting the actual cell in here, but now we're doing it over here to then pull it on the neighbor's chunk. And then similarly, the little formula we just made for grabbing these cells will just be applied for these cells. This variable needs to be found within our neighbor tile map. That needs to be converted from a byte to the tile enum, or the tile enum to byte to integer. Get that from the tile rules. We're going to do top to bottom, bottom to top, left to right, right to left. We're doing this inversely because excuse me. We're actually checking the our directions. Remember, this is set in the very beginning of our function, and therefore we are checking, when we're checking the top direction, what we want is the bottom neighbors. So what does that mean? So let's say we are currently checking cell 0. So we want to make sure that we're getting its bottom neighbors. We care about and are interested in what exists below it. That way we know what we need to place within this cell, within cell 90. And then similarly, if we're checking the chunk in the right direction, now we want to pull its left tile rules. And that's why each of these have been flipped around. We're going to set that as the neighbor rules set. We are then going to find our current cell index within tile options. If it does exist, we need to set that as a ref. If it doesn't exist, that means we can go ahead and just set our tile options equal to the neighbor's rule set. Now, why might we find this? Well, we might have already in the case, this won't happen often, but if we have chunks that exist already, if we're trying to collapse this chunk right here, but already this, and this have been collapsed, there will be instances in which these quarters overlap and will already exist, and we will need to remove them from the entropy array as they may get updated differently. So our algorithm starts by checking top, bottom, left, then right. So if we do a top check and then a bottom check, this might have been updated already, as well this would have been updated since this exists, and then we check the left, we're going to recheck 0, so we want to make sure that we properly get its already set potential tile potential tiles. This is sorry, it's a little bit obfuscated. All right, but then we're going to just do the classic remove from entropy array at tile options current cell. Then we need to do the create and check new tile options on the neighbors rule set, and that's ref, and then set that as the new ref, which will then, oh, and in this case, we actually pull off of identical old and new options. I'll try to explain that in just a second. Then we need to add the new options to our current cell within the tile options, and then add that to the entropy array. So we can use that when we want to collapse the whole chunk. Now, why do we use this where we haven't used it before? Well, there's a bit of an interesting thing that happens when trying to actually, I'm trying to think, is this even matter anymore? The reason I had this, I haven't actually tested it in a long time, was because we would come through. Honestly, we're just going to leave this for now, and I will do further testing to make sure if we need this anymore. This mattered more for when I would use an older algorithm to update neighbors, but we'll leave that for now as it won't do any harm. Perfect. The next thing we need to go ahead and do is finish out the collapsing of the entire chunk. Now, how are we going to do that? Well, we go back into the event graph. We've set the chunk position, checked the neighbors. We can print the tile options. In fact, I'll do that. Let me disable. And we'll see, this is going to actually print out the tile options. We'll see at, for this chunk that we can't see yet because we haven't collapsed it, we will see that it now has proper tile options existing according to, oh, that was an incorrect F2. According to what these should be. So to the right of here, the right of here, and the right of here, we have different cells compared to the others, which are all just blank top left and left. As up here, have I forgotten? There we go. Up here is just those blank tiles. Perfect. Now, if we want to go ahead and spawn that in, we can propagate the collapse, but we need to make a few changes. Within spawn chunk, we now care about chunk positions. So we need to make sure that when the paper tile map component is added in, its relative transform isn't just 0, 0, 0. It's actually something like this. It's going to be the paper tile set tile size. This is a part of the paper tile sets that I realized, and we're going to use this in place of the tile size. So in fact, if you'd like to come to create new tile map, you can get rid of tile size and instead get from your paper tile set, get the tile size in the X and Y. That makes so we don't have to hard set anything. So we need to multiply a few things. We do the chunk size, tile size in the X, chunk position in the X, and the scale of the tiles in the X. This will get how large a chunk is and what location it is for the chunk's position. And then similarly, we'll do everything in the Z or the Y, the vertical direction. So scale, chunk size, chunk position, and tile size. And each of those will make up that vector, which will then spawn in. Perfect. And if we were to go ahead and just run that, we'll then see that we now have a second chunk that generates. So I hope that made some sense. That was kind of a lot. And I will explain and double check in the future why, if this still is necessary. Essentially, what used to happen is there were issues with updating, pulling some of the information from others, and it would just get kind of weird and do a funky little bug. But with the forward checking, that might have actually fixed that. So please feel free to ask any questions. And yeah, I'll see you in the next one.